Eu sei se você quer. Não, perfeito. Miss Thomas, you doing my work, Miss Thomas?
How y'all doing, class?
Good.
All right. What's up, Mr. Spooner?
Doing fine, sir.
Mr. Spooner, I think on one of your assignments, in your header file, you had header dot, and you didn't have the dot H. Did you look at that? I think I put in the comments. And I think I went on there the dot H, and I took a few points off, whatever. But like I said, that made your program have an error.
Was it for the first program?
Couldn't tell you. We could look, but we could go over the program so that we can see just what was asked or needed. Can I look at your programs?
Sure.
Okay, all right. So what I'll do, I'll pull up your program. All right, one at a time. I'll go through them, and we'll look at it and see what I was looking for, what I took off, why, whatever, and what could have been done. All right. So I'm gonna go to grade right quick. I could have went to your name, I think. I'll go here. Spooner. Okay, here. So Mr. Spooner on 3-1. Okay. No, so Spooner. All right. So let's look at this first one. Let's see what happened here. All right, speed grade. All right, so let's look at this one. What happened said program errors, there's a problem with your declaration statement, okay? It said you did not use online GDB to compile the program because you do not need, wait. Because you do not need to initialize variables before using them in online GDB. Remember we talked about online GDB and how that it was not as strong compiler as Visual Studio. Remember we talked about that? And I think you sent me an email on that, right?
Yes, sir.
You're right. So look at this. Here you have what it was on the equal side. You have prod val, right? No, not that one. It's something that's on both sides of the equal side. I don't see that. Where is it? It's one of those values. Let's see. Oh, it's not there. Prod val modulus 2 equals 0. I don't see where it is, but and I don't know why I said that, but let's see. I have to remember. Was that on this program or that was on another program? Had to be this one. Right. Well, it's this one because look, you said prod val to well, you didn't even set it. Well, really, let's see what you did here. You really set this equal prod val. Prod val don't even have a value at this point. So it's like you're trying to set even val to prod val in this particular statement, and prod val don't have a value. You understand what I'm saying?
Yes, sir.
With online with Visual Studio, you'd have automatically gotten an error. With online GDB, it said, okay, he didn't give a value, so I'm gonna assume that it's 0. You got what I'm saying? So
yes,
it assumed that it was 0 in online GDB. So I took points. I kind of took points, but I still kind of initialized it to 0 and ran the program, and I gave you some points for it. All right. So in this program, you were to input 3 different values, right? Input 3 different values and get the sum. So now you did it this way. I think I asked you to do the first one, second one, third one, fourth one. Not too worried about this one, but I told you for that other one, I specifically said all at one time. It was test grades, test scores. So you input them, you found the value of product val, which is good here. But see, in here, you got header.h as a header file, right? You're loading it, but you never call the header, right? You never call whatever the function name in header.h. So therefore, it'll never execute your what? Cout statement, right?
Right.
Even though you gave me the what? The .h file, but the program itself is never calling that function. And let's click on this and we can see what your function name is.
Okay.
You got what I'm saying?
Yes,
Right.
sir.
So it's never going to execute or call head to execute programmer Nelson Austin Spooner, cout course name. You got me? So that
Yes,
won't
sir.
never print. Okay. So that's the reason for loading the header file so that you can what? Call those functions, that function and execute it. All right.
Yes, sir.
Now, but then the rest of the program, pretty much you got your set precision to 1. Let's see. Yeah, I think I said the set. I don't know if I specified a set precision value, but what this does, class, fixed show point set precision. What that does, that actually allow me to print out each one of my decimal or float values with 1 decimal place. Okay, with 1 decimal place. So if, let's see, but you have what? Int, all this is int. So what? None of these will print what? 1 decimal place, correct?
Correct.
Because they're all int. All right. So it's stuff like that. You got to be mindful. You got to watch. Now you got your if statement. All right. If, now, which is good. If prod val modulus 2 is equal to 0. So that's saying if prod value, the product value is 10. 10 modulus 2 is equal to what?
Equal to 1.
10 right. 10 divided by 2 gives you a remainder of 0. So therefore, it is true. It is equal to 0. So what? It would output the number, whatever is even. Otherwise, it would print the number, whatever is odd. Right? So that part is correct. You did a good job done. All right. So that's no problem. But everybody see what happens here. What I was looking for and whatnot. All right. Any questions about this program? All right.
Like, I don't have a question about this program. Like for the text, sir. Like, what do we upload for text?
What you mean for text? Like say the prompt?
Yeah, like when you submit an assignment, it asks for the CPP, the header file, and
No, that's just, don't worry about that. That's just added. Nothing.
Okay.
All you had to do was, because this is why I do it at times. Some people may how would I say it? At times, some people may have issues with, okay, I got a .h file, but I need to submit it, but they save it, and they save it at .txt. If they still submit it, I could look at it and say, oh, that's the .h file. I'll go ahead on and accept it. But some of them will try to submit a .txt file and say, oh, I didn't submit it because I couldn't. It didn't allow me to. So that's the only reason for that. But it should be .h, or .cpp. Right.
Yes, sir.
Okay. Let's look at the next one. All right. Mr. Spooner said I could look at his. All right. So let's see. Let's see. The next one is 3 point whatever. So let me move this up. Move this over. Spooner. All right. Let's see. All right, Mr. Spooner. So 3-1. 3-2. All right. So we look at this one. And let's see what we did here. All right. So this was the next one. The next program, okay, now you have your header file, which is cool. That's good. Let's see something here. You don't have what? You never call your what? Your header function. You got it? And look, you're loading it, which is good. You're loading the header file, which have what? It should have IO stream in it, Okay, you got your IOMAN IP to use the percent precision and whatnot. And then you even have your CMAT to do if it's power or whatever, which is good. But you just never what? You never called that header file. All you had to do in here was say head, open, close parentheses, semicolon, right?
Right.
Okay. All right. So now in this program, you had to input the first name of the employee, well, first and last name of the employee, the job title of the employee, and look, and I told you it's first and last name, you got a space in it, so you have to use what? Get line, right? You got to do it because it's going to read up until what? You hit the enter key. Same thing for the job title. A job title could be one word or it could be multiple words. So you want to use get line to get all the way to the what? To the enter key. And then CN wage, all right? And then CN hours. Now, you couldn't use int because I wanted what? Decimal places, correct? And
Right.
then two, a person could have worked 10.5 hours. You know, they want their 0.5 hours. And then they could have a wage of $8.25. So you got to be aware of that. Now, so you input the wage, you input name, first and last name, job title, wage, and hours. Once that's inputted, and I'm saying that because some people in some of their programs they did the input of the data, you know, but they never generated the output. So it's like they ran the input of it, and that was the end of the program. And I'm like, well, wait a minute, where's the output? You never did the calculations, you never did the output of the headings and the values. You know what I'm saying? So they pretty much did half of the program. All right. So now once the data is inputted, now what? Float was, and all they did was declare their variable here. They could have declared gross pay at the top, no problem. All right, remember we talked about programmer style. Gross pay is equal to wages time hours. So that's going to be stored into the gross pay, which is good. All right. Then once they got the gross pay, they see out the header. You could see out the header because you're not seeing out anything after that. But the thing was, some people outputted name, then the name, new line, job title, what the job title, new line, wage hours, what's the hours, new line. That was not the format. The format was name, 30 spaces, job title, 25, column with and then gross pay, I think it was 12, going across. But some people just printed it going straight down. It was supposed to be printed going across, right? But this is going across. It's just that all he did was broken down his statements to where it's not going across the entire page where you can't see or they have to ramp, which is good. And he ended it with a semicolon. So he got what? Left, which is right, which is correct. Set W25, and then he going to output name. So to the left margin of the screen going to be name. Then he got set W30. All right, after the 25 spaces, and you're going to put name to the left of that, then it's going to move over, go this way. Then it's going to move over 30 spaces, and to the left of that, it's going to put job title, all right? Then, after that, he's going to say right, and then set W10. So after those 30 column spaces, he's going to move 10, and now all of a sudden, he's going to be printing from the right, coming to the left, and he's going to print wages. 10 gross pay, 12 taxes, 12 net pay. So that's the column heading. But then he has his calculations for his gross pay. But I'm looking for the calculation for taxes. Oh, it's inside the form, inside the output. You can do it that way. We don't try to teach it that way, but you can do it that way. So he did see out left again, set W25, and then the actual variable called name. So that will be under the first thing printed under the 25 columns to the left. Then he moved over 30, all right? Within those 30 columns, to the left, whatever that job title is, all right? Then he'll move over 10, and then he got to the right. He said, okay, now I want to print from the right coming to the left, and then I'm going to set my decimal place. Wow. What he did here, he didn't do the decimal place. He did show point, set precision 4, but he's missing the word fixed, all right? So he got 4, so now we're going to have 4 decimal places in a sense. Or it's just going to be 4 significant digits. He got the set precision, but he don't have the fixed, all right? And then now, he did wages, and it wasn't fixed. But then now he did fix here 2, fix here 2, fix here 2, fix here 2. So, and I'm imagining wages is still a dollar amount. So this one is wrong. For hours, it should be what? 1. Set precision to 1. Remember, I told you I only wanted 1 decimal place for the hours, and 2 decimal places for all the dollar amounts. And he printed his taxes by saying, okay, see out, not a variable name, but gross pay times the 0.172, which would give him that tax amount. And then for the net pay, he didn't create a variable. What he did, which is net pay, but what he did was he just put a formula, gross pay times, which is wrong. Gross pay minus gross pay times 0.172, which you could have just said, which is right, which he got the right answer. But what he did, he created variables, but he didn't use the variables, he used the actual formula. All right? So that's this program. Anybody with questions on this one? Any issues? But I wanted the output to go across the screen. Name, job title, I think it was wages, hours, gross pay, taxes, net pay. Then whatever the name was, whatever the job title, whatever the wages, whatever the hours, whatever the gross, whatever the tax, whatever the net pay, going across. Okay? All right, so that's that second. And like I say, make sure you do the headers. Like I say, we went over that the first couple of class periods. Let's look at the next one. All right. So the next one was, let's see something. The next one was 3. Yeah, Mr. Spoon, I don't know what you did on that one. Let's see what you did. All right. On this one, program errors, average score, okay, not declared, and then no output. So you were one of the ones, I was talking about. Now, let's look at it. So let's see what happens. He got his header file. He got his function declared. And he got his headers of IOStream, IOMAN IP, CMAT. So he got those. Remember, I told you, you always can have more header files than you need, but you have to have the ones that you're going to be using. Like if I'm going to use fixed or set W, I have to have IOMAN IP. But if I don't have IOMAN IP and fixed and set precision, I can load IOMAN IP. I won't get an error. Okay, but like I said, you can add as many header files as you want and not use them. But if you're going to use a function from that header file, you have to have that header file loaded. So let's look at its CPP file. So it said program errors. So looking at this, Mr. Spooner and class. All right. So the program here was to allow you to input 5 test scores at what? One time, correct? Now, I had a couple of students use arrays and loops, which was so good, but some of the programs were similar, so I couldn't give them credit. But if you look at this, you got double, score one, score two, score three, score four, score five. So that's his variables. Now, but he forgot what? One variable, right? Right, class? He forgot to declare what? Average score. The computer don't know what average score is, correct?
Correct.
So now a simple way to fix this, you could have just put int in front of this, because this is when you first introducing it, right? You could have said int average score equals, and all of this divided by 5. That would have worked, right?
Right.
But, okay, and well, then you see out fix, show point, set precision, 1, but you're not outputting what? Test 1, test 2, test 3, test 4, test 5, average, the first test, second test, third test, fourth test, fifth test, and then whatever the average is. You understand what I'm saying? So you did the input, and then you had a statement for the calculations, which was wrong because the variable wasn't declared, but you didn't even finish writing the program to do the output. You got me?
Right.
Right. So you see, yeah. So when you write, and you gotta understand, when you're writing the program, most often it's input, process, and output. You know, that's what you're doing. Inputting the data, calculating something, reorganizing something, checking to see if something, and then output. Yeah, so because you don't want to just be able to input it and then not be able to do anything with it. Input, process, and output. Okay? All right. Anybody with questions on this program? Now, I had some students to do their formula wrong. And what I mean by that is, see how Mr. Spooner have the parentheses around the test scores? That's the correct way to write that formula. Without the parentheses around the test scores, remember we talked about the order of operation? This is plus, 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 this is divide. So what would happen if I didn't have the parentheses? A multiplication and division has a higher precedence than addition and subtraction. So without the parentheses, it would divide whatever test 5 score is by 5. Then it'll add test 4, test 3, test 2, and test 1. Therefore, you might have an average of 400 and something rather than an average score of 100 or from 100 to 0. Everybody understand that?
Yes, sir.
Okay, all right. But some people did that. They forgot they parentheses, right? And I know you get excited sometimes when you get output and like, oh, I got it, I got the output. But check your output. And I'm saying just do it simple check. Like say, okay, let me go through it. Let me take a calculator. If I got 5 scores, and what you might want to do, you might want to make it obvious. If I make a 5, 5, 5, 5, 5, 5, 5, 5, and 5, what that average should be? If I got 5 test scores and I make a 5 on all test scores, what that average should be? Class? It should be 5, right? If I have 5 test scores and I make a 25, 25, 25, 25, 25, 25. If I do an average of them 25, it should be 25. So that's what I'm saying. So just find, it'll be the number 1, 1, 1, 1, 1, 1. What's the average of 5 ones divided by 5? 1. So when you do one of the most simplistic of calculations and see if it works. Because sometimes, man, sometimes you might mess up on an addition sign, a division sign, or something like that. All right? So any questions? Questions? All right, let's look at the last one. I think it's the last one, yeah. All right. Now on the last one, I gave you an algebraic expression. Now, for some reason, and I don't know, I get this every semester. I don't know why, but at the same time, I mark it wrong. and I tell the students, and let's look at it first. All right. So I gave you an expression. Let's look at this. So see here, still you don't have what? That header function being called. But look, I gave you an expression. Let's look at this right here. The square root of b squared plus 4ab. Now, is it 4? Did I say 4ab and c? Or ab? 4abc. Let me look at that. 4ab. Right. No, see, look, 4ac. You see here? You understand? So some people, what they did plus or minus b. Now, when I saw that, I'm thinking, okay, what they thinking is the quadratic equation. This is not the quadratic equation. And what they do, they go and they find a program online with the quadratic equation, and they try to write it and give it to me. That's wrong. It's similar to it, but it's not the same. All right. The quadratic equation is something like plus or minus the square root of b squared plus 4ac over 2c. You understand? So you got to be mindful of what's asked of you. All right. So let's look at this. See, I got incorrect formula. So let's look at what his formula is. His formula is very close. Now he didn't make a mistake of trying to do plus or minus for the square root, but he made a mistake here. Let me make this bigger. Y'all might could see. He made a mistake by adding what? A b into the formula. Correct, class? Everybody see that? That's his only mistake. The b. What's that? Somebody said something?
I was just reading the formula.
Oh, okay. All right. Right. So see, and then like I say, his header file. He ran in his values. Good. He had his formula minus this, and then he had his answer. You know what I'm saying? But and like I say, he did the set precision. I didn't ask for a set precision, but he gave it. That's cool, no problem. I don't have an issue with that. You know what I'm saying? But if I specify something, make sure you give me what I specify. If I say make sure it's a whole number, don't give me nothing with set precision. You got me? But he used set precision. I won't hold that against him. But the formula was wrong, and he didn't have the header file. All right? All right, class? Well, not say and he didn't call his header function. All right? Any questions?
No, sir.
Anybody with any questions? Questions? All right. So, anybody with any questions about the test, the quiz, whatever? Any questions? So everybody pretty much straight? All right. So let's look here. Our next chapter. And I didn't post anything. I was in the seminar. I was in our conference. All right, we're going to have chapter what? It's chapter 5, all right? It's going to be chapter 5, correct? Yes. Chapter 5. And then I'll open up chapter 5 quiz. And like I say, is it the 12th? Yeah, it'll be around. I'll leave it open till the 12th, 13th. All right. So I'll leave this open till the 13th. So you have that extra day. What's going on here? All right. Okay, so that's published. Okay, that's the quiz. All right. Then let's look at the assignments. Now, in chapter 5, it's dealing with if statements, right? So, or like conditions. No, this is loop script right there. We did the if in chapter 4. All right. So this section or these three programs, all right. These three programs going to be the exact same program, but you're going to use a while loop for one, a do while for another, and a for loop for another. All right. So this says write a program using a nested loop. Well, no, scratch that. That's my 192. Using 2 of the 3 loops are discussed in chapter 5, which we're going to discuss in a while. Right. That will allow a user to continue calculating the average of 3 numbers entered if their choice is yes or is Y. Now, this is what's going to happen. We're going to write a program using a loop, and what's going to happen, you're going to prompt the user. You may prompt the user or either fall into the loop. Please enter your number. Or you could ask the user, do you want to average 3 numbers? If they say no, it'll just kick them out and they finish. If they say yes, then it'll start, fall in the loop, and allow the first number to be added to a sum. Then ask them, please enter another number. They add the next number. Then, do you want to enter another number? Yes. Then they enter the third number, and then it should know it's the third time, and then it kicks them out, and then you're gonna output or calculate the average, and then output what the average is. Right. So enter a number. You enter the first number. If you say yes, enter the second number. Okay, yes. Enter the third number, and then whatever. Then after you enter 3 numbers, kick out. Enter the average, and calculate. Enter another. But let's see. No, let me make it a little simpler. All right. Fall in the loop no matter what. Okay, and do it 3 times. And then after you average the first set of 3s, ask them, do they want to calculate another? And I'll go over that when I go over the notes. All right. So no matter what this program no matter what happens in this program, you will allow the user to input 3 numbers. Then you're going to calculate the average. Then you're going to ask them to input, decide whether or not to calculate 3 more numbers. They're going to continue again, inputting 3 numbers by you prompting each time for a number. Once you input 3, I'll put the average. Then I'll ask them if they want to input 3 more numbers to average. All right. But then you're going to have it in that continuous loop. And when they don't put Y, they put anything other than Y, then they exit out. And we'll look at that based upon our notes in a little while. But let me edit this and let me change that date because it probably has the 12th also. .h.cpp. Let's see, July 16th. I can make it do this thing. I'll make it do at the end of the class. So if you got questions, I can answer. I can answer your questions. But don't wait till the last minute. All right. So that's that one. It's published. The next one. All right. The next one. All right. So what we're gonna get into? We're gonna get in databases now. Not databases, but data files. It say using Visual Studio or online GDB. Type in the following command programs. Now these class programs are already written. Let me download it. Let me download it to my download folder, and let's look at it. All right. So looking at this program, what I did to this program, I kind of dissected it for you so you can kind of see what's going on in each area, all right? So it's telling you, first of all, this program will read data from a data file, okay? It will read data from a data file. In order for me to do that, I need F-stream header file loaded. I need to define my data file object. IF stream, IF is for input file stream, and data file is my object. Now, anytime I have an object that I've defined, I have to associate it with an actual physical file. And I have to open that file, assigning it to that object. So data file dot open, and this would be the file name that it's looking for. Now, another thing about this, depending on your computer, you need to know where is the default folder that file is to be found. Because if the computer cannot find the file, you'll get errors, right? Now, once you open the file, anytime you want to read data from that file, you have to use a file object, which is data file, not CN. If I use CN, where I'm reading the data from?
The keyboard.
Bam, the keyboard. So I created an object saying that I'm gonna have an object called data file. Now your object could be called data1, it could be called input1, it could be called any valid C++ name, variable name. It would be your file stream object. And but like I say, whatever you create here, you have to use it here and have to use it when you want to input the data. So looking at this program, this says while not data file EOF. EOF stands for end of file. There's many different ways you can read data in a file. This particular example allows you not to have to count how many records are in a file. It'll read until what? The end of the file. All right, everybody understand that? Now, but there's many different ways. If I know I have 5 records, I could say for int x equal 1, x less than 5, x plus, or x less equal 6, x plus plus, and then it'll read 5 times, you know? But what happens when I have a number that I can't count easily, like 3,487, you know? If I do this, it's just gonna read each record until it gets to the end of the file. We're going to talk about records later. Now, so that's using the object. But now when I output the data, if we look here, I'm outputting it where? Cout outputs where? Where does Cout output the data?
On the screen.
On the screen, all right? So the data will be outputted to the screen, and then data file.close, you're doing housekeeping, you're closing the file. So like many times if you're working in an environment, when you have access to the file, you have it open, nobody can use it until what? You release it. So that's good housekeeping to close the file and make it available for others to use. All right. Now, I'm gonna show you something. This is a loop, right, that will continue to perform until the end of the data file, right? This loop will continue. But look what's happening in this loop. I'm reading in name and I'm reading in num. But look what's happening here. Total is equal to, total plus equal num. That's simply saying what? Total is equal to total plus num. So what's happening to total each time we're going through this loop?
It increases by the number.
Right, it's being increased by the number that's being read in. So I'm accumulating the total value. All right, so like I'm getting a value from the first record. If the total gonna start out as 0. And notice here, remember I told you this. In C++, well not Visual Studio, you have to do int num equals 0. Well, not net num equals 0, but total equals 0 because total is on this side and total gonna be on this side. So it needs to know what total is. If I try to run this program in Visual Studio, I don't need in online GDB, I don't need to say total is equal to 0. I could just say int num total and total semicolon. But in Visual Studio, I have to set it to a starting point, and so that when the first record read in, it says 0 equals 0 plus whatever that number, and it's going to know what it is. All right. Now, but each time I'm going through the loop, I'm outputting the name to the right within the 8 columns, and then to the left, I'm outputting in the actual number that's being read in. All right. And then it's going through the loop again, reading, adding to the total, outputting the name, outputting the number. Going through the loop again, read the name, read the number, incrementing the total, writing the name, writing the number, until it gets to the end of the file, and then I'm gonna output total, and then whatever my total was calculated to be, closing the file and end. All right, so this is an example of the program. This is what I want you to type. The problem may not be in you typing this program. The problem gonna come with the data file name, where it's located, how to do it in Visual Studio, and stuff like that. Everybody got me? So, but we're gonna go over that, okay? So that's where the issue gonna probably come. But like I say, you look at this program, this gonna guide you into doing that assignment, all right? So it says, look at this, because you're gonna have to create or type in that program that we just saw, but you also gonna have to type the input file. All right, and what I'm gonna do, I'm gonna show you the input file. All right, this is the input file. Tim, 10, Bill, 20, John, 30, Rick, 40, Mike, 50. Everybody see that? Now, you say, well, Mr. Vesta, how I'm gonna create that file? Well, let me open up Visual Studio real quick. In Visual Studio, there's a way you can assure that the file that you're working with is it will be found. So what I'm gonna do, I'm gonna just open up a file that I already have, that I kind of use. All right. All right, so now what I'm gonna do, I'm gonna take all this out. All right. I'm gonna put this back. All right, so here, so I've header file, right? But now we know that's header, and I just have that, in the, but if I wanted to create a data file or a file for input, an input file, in Visual Studio, and I think I have it in my how-to videos on my SYL site. You can go to the right of this in here. Now, if you don't see this when you're in Visual Studio, simply go to Window, go to Reset Window Layout. I'm gonna ask, are you sure to restore? Yep, you're restoring the window. And it gives you the window, no problem. But what you can do, if you want to create a data file, you right-click on Source, you click on Add, you click on New Item, and now you know you can create the header file, right? You know you can create that on the CPP file. But this time we want to go to Utility, and we want to create a text file. Who is that? Mr. Lamana? Mr. Lamana, I think that was him. He had asked about that .txt file extension in the thing. Now you're gonna see that. Sir. Yeah, now you're gonna see that should see that in this particular assignment. So you're gonna upload the header file, the .h file. You're gonna upload the .cpp file, and you're gonna upload the what? .txt file. So that's 3 different files this time, not 2. Everybody got that, right? Yes, all right. So now, what I do, like I said, I click on the source files, then I leave from code and I go to utility and I click on text file, and then I can give it a name. I could leave it default as text.txt, or I could give it any name, .dat, whatever name, whatever, because that's the name I'm gonna reference in my file. So all I do is simply here, click add. Now, notice here, this file is associated with my program here. So now all I need to do is start typing Tim whatever. John, I don't know what I had in there. And you understand? So you're going to type all those names and with a space between the name and the number, right? You're going to type that and you're going to just, it's saved, all right? So that's saved. Once you do that, you're finished. Now watch this. What I could do here, I could do that pound include. Right? I could put it here, or I could have put it in this header file. Long as I'm what? Loading that header file, but in this one, I'm not loading it. All right? So now I have that, okay, using namespace, and then I can create me a file object. IF stream, because this is an input file. And I'll just call it, I'll just say CSCI 193. That's a valid name, right? It might be confusing, but I'm just showing you that it does not have to be data file. It doesn't have to be input, whatever. Any name that you associated with, because I might have, I might be working with a company, and that's the specified name that they're given. And you're like, well, no, Mrs. Vesta said the name got to be data input. That no, any valid C++ name, right? Object at least. Now, what happens is now I do my CSCI 193. Well, what I did, CSCI 193.open, and then what would I put in the double quotes? I'll put the physical file name. So what's the file that has the data? It's text.txt, right? .txt. Any other name, I'm gonna get some errors, you know, or I might be pulling in a file where it doesn't have the right format. You understand what I'm saying? So I have to make sure that whatever data file that I do create in here, I have to actually open that file. Now, I would say this, with Windows, if you've used Windows a lot, Windows doesn't matter whether something is uppercase or lowercase, right? It does not matter. But if you on a Linux system or a Unix system, it does matter. So I would tell you to stay in the habit of however you create your name, create it the same way. If you made it all caps, make it all caps in the application. So that way, if it's used on a different platform, you won't have any issues. All right, but because Unix and Linux, they are case sensitive. Windows, it don't matter. I could have a file called capital TEXT and a one lowercase, all lowercase TEXT is going to look at them both as the same file. All right. Okay. So what happens here is, now I could do this several ways. I could use a for statement, which we're gonna go over later on. If I know I got 3 records, right? I could say for int x equals 0, x less than 3, x plus plus. And then in here I could say what that is, CSCI 193. I got to get my variables, okay. I'll have to say string name int num. All right, so now I got my variable. So now I want to input name and num. So each time the computer gonna read, right? Every time it goes into this text, it's gonna say stream in name, which is Tim, and num, which is 20. Next time, name, which is John, num, which is 233. All right, so that's what's gonna happen here. All right, that's what's happening in here, and it's gonna do 3 times because I got it set that way. All right. Now, what I need also is a total, and I'll just say equals 0. So now in here, if I want to accumulate my number, I could say what? Total is equal to, I could do the plus equal num, and I'm finished. Or I could say total is equal to total plus num. Either way, Both of those are the same exact statements, right? And then within this, as I read my name and number, I could do a cout. And then I'll do name, which is name. All right, so I'll do that. Now, because what happens is, if I'm reading 3 different records and I'm reading a name, every time I read in a name, it's gonna wipe out the previous name. It's gonna wipe out the previous number. The only way you can attain or retrieve or hold those names and numbers if I would do an array. And we'll talk about arrays toward the end of the semester, all right? So now, this is very important. I do not want to print the total inside that loop, right? Inside the loop, all I'm doing is reading the name, total, name and number, totaling the number, print out name and number. Okay, I'm not finished. Reading the name, print, calculating the total, print out the name and number. Go back, reading the name and number, calculate the total, output the name and number. Oh, I'm finished. Now I want to output the total. All right. So now I could do a cout. All right. So now, so that's basically what the program should do. So it should what? Output Tim 20, John 233, Brian 84. And then once it get out the loop, it should give me my total. So when I run this, all right, I'm gonna just go and debug it. All right, so look what happened, class. Name, and look, what it's doing. All these are what? Pretty much patterned the same way. I didn't have to keep writing out name, whatever, or name, number. I mean, number, name, number. It did the loop that many times, all right? So see here, so it added what? 20, 233, and 84. Let's just look at the end numbers. 4 and 3 is 7, so that's 7. So that's pretty much 8 and 3 is what? 12. All right. Is that 8 and 3 is 8 and 8, 10, 11. Oh, 12, 13. Right. Plus the 2, that's 13. All right, carry your 1, 2, and 1 is 3. So that's right. That's 337. That's the total. All right. So everybody kind of see what's happening. Now I'm gonna show you something. If I mess up and do something like that, like test 1. Now I'm opening up test1.txt. My program name is test1. Watch what happens. See here? Nothing happened. I got an error because it cannot find that particular file. You understand? So you got to make sure that program, you know, that file is actually listed, because if not, like I say, you'll run into errors. Now in the book, in that chapter, it shows you how you can write some code to say, okay, if it's not found, file not found or whatever. All right. So remember here. Now check this out. This for loop will do how many names? Only 3, correct? Well, n equal to 0, x equal to 0, x less than 3, right? That would loop what? 3 times. Check this out. I could go back to text and I could say, okay, I'll here do this. All right, so class, I have 6 names in this field, in this record. All right, I go back to my program. If I run this program, how many names will print? Anybody? How many names will print?
3.
Only the first 3 names will print. Only because I'm telling it to do it 3 times. I'll put the total and then what? In. Now what I didn't do my housekeeping, which was what? CSCI 193.close. Right, to close the file. Now, so it will only do 3. You say, well, how you know, Mr. Sylvester? Watch. When I run this, what I did? Oh, is it down here? All right. See, it only did those 3, but let me close this and run it again here. All right. See, it only did those 3. Now, if I change that 3 to a 4, how many will it do?
Do 4.
It'll do 4. All right. So, and if I run it now, it does 4. You got me? So that's that loop. They're going to determine how many I do. But what was that other thing it said? We had what? It said what? While not what it was. CSCI 193, and I think EOF, right? Is it C while not CSCI? That should be right. This. That. I think that's right. Let's see. While not. Hold on. Let me pull out that program again. My end of file. And I got my end of file statement wrong. Not this one. This one. All right. Oh, I got it right. Oh, dot. I'm missing my dot. All right. So this should be a dot, not a parenthesis. Oh, yeah, because I got too many parentheses anyway. All right. So now, while not my file object in the file, continue reading. So I could have 1,000 records. It's going to do what? All 1,000 records. I don't have to count to try to match it or whatever. That EOF is going to say, read till it reads that end of file marker. All right. So now when I run it, all right, I'll do debug and I run it. And what? It's going to do all 6. Because it's controlled by the end of file marker. Everybody see that? Questions? Anybody with any questions? All right. Okay. So that's pretty much how that program runs. All right. Like I said, you got to have the file stream, got to have your object, got to have your object open to that text file, create your text file. And then when you're reading in the data, you read it in, you read from using the file object. All right. All right. Now, no questions? All right, so let's look at, I think was that the last program? No, one more program, all right? So it tells us that once you type view the how-to videos from the SYL website to create your data file in your respective compiler, but do it in Visual Studio. All right, test the program and remove any and all errors, making sure that your output is correct. So make sure you check your output, class. Don't just get output and say, oh, I got it. Upload the completed C++ and TXT files. So whatever C++, .h, and the .txt file, all right? Also be prepared, well, we ain't gonna do the demo part, all right? But your output should look something like this. All right, and then I still gotta open that up. All right, so your output should look something like this, because I gave you right alignment for everything, and then your total, and then whatever that total is. All right. Questions? Questions? So that's that program. So let's let me edit it and publish it. All right. All right. And the last one for this chapter. Now, this time, class, all right, well, okay, the previous program, we had to what? Type in the data from what? Well, read the data from what? The data file and write the data where? Where the data was written to. We read it from a data file and wrote the output to what? In the previous program example that we saw. Anybody? Hello, class? Hello?
Into the program?
Well, we read from the data file, right? And then we calculated the sum, the total, and we outputted the total to where?
The screen.
To the screen. Now, check this out. This program, you're gonna read from a data file, but you're gonna also write to an output file. So you're gonna read from an input file and write to an output file. All right? And this is what computers are basically doing all the time. Give you an example. When you register on a website, right? You putting in information, correct?
Right.
Many times it's reading information from somewhere, but then you writing it in, and then they don't give you an output of what you inputted. It just goes somewhere. So when you log in the next time, what? You can access that data or you can access their site, correct? So that's somewhat what this is. You're gonna read for data from a data file and write data to a data file. So let's look at it. Using Visual Studio, it says all online GDB, type in the following program, all right? And that's basically this program, I give it to you. Let's look at it. And I'm gonna show you some of the differences. In this program, I dissected it again. Look here. F stream is the header file. You have to load it. But look here. You got IF stream, which was from the previous program. Because see, all you're doing is adding to the previous program that you already had, if you got it right. So you already have IF stream data file, right? So you read from the file already. You got your loop set up already, but check this out. You got another object introduced, OF stream out file. OF stream is for output file. So now you're gonna have a file associated with data that you're gonna have output to. So we're gonna call that object out file, okay? So now, just like we had to open up a file to read from, we have to open up a file to write to. So look at this, outfile.open, output.txt. This file you do not create. The computer or the compiler will create this file. Everybody understand that? This file will be automatically created by the compiler because you're gonna give that name in here, whatever name you give. I could do a.txt. A.txt will be the file that is gonna write to, all right? Whatever that name I give here is gonna be the name that is gonna write to. It's gonna automatically create it. When you get in 194, we're gonna go over some iOS flags that you can use to determine whether you wanna open it for input, open it for output, append it, delete it, or whatever. So, but right now, all we dealing with is the basics, all right? This one opens for input. This one with the IF stream. This one is open for output with the OF stream. So now, looking at this program, and basically, you're gonna take the previous program and copy it. And the highlighted portions of this program is what you're gonna add to it, all right? So look here. This is our loop. We read until the end of the file. You should already have your data file. So what? Reading in name and number. Calculating the total from number. But then what? Where are we writing the output to? Where are we writing the output to?
File.
So what the file name?
To output text.
Right, output.txt. Because out file is just the object that's associated with that file name. So I can't use cout. If I use cout, it's gonna output it where?
On the
To
screen.
the screen, right, to the console. But when I use cout now, so what? That same statement I had in my program before with cout, now replace cout with out file, right? And then even with the cout for the total, I replace the cout with what? Out file. And then I'm closing my out file object, and then I'm outputting what? The program has completed successfully. Now, so what I'm gonna show you is, if I go back here, so we have this program, correct? I'm gonna make a few changes. So here I'll say OF stream. I'll say CSCI out, all right? I'll just call it that. I can call it whatever I want, all right? Now, I'll go in here and say CSCI out, and I'll say dot open, and this is why I have the luxury to give it a name, all right? And I'll put in here, I'll say data dot out. I'm gonna give it any name I want, right? I'm the programmer, unless I'm working with a company and they're telling me what to get, what file name to send it to, all right? Now, all right, in here, rather than output to what? To the screen, I wanna output where? To what? Where would I output it to? What would I use rather than I use cout?
A CN.
I want to output this data, but I want this data to go to my output file, not the screen. So what would I use? I'll use my output file object, which is, what's my output file object?
Data out.
That's the file name, CSCI out, remember? Just like when we did here, CSCI 193 is the object, it's not the file name. You got me? So in order for the data to go into data out, and for output, I have to say CSCI out. That's the object name, correct?
Yes, sir.
And again here, if I want my output to go to my output file, CSCI out, correct? Now, just because I have an output file doesn't mean that I have to write only to the output file. I could do something like this, cout. PROC is once PROC is a process. I think that's right. All right, process has ended. All right, so that's just gonna let me know that, hey, my program is finished rather than me just looking at the screen. So now, watch what happens at the top of this, this bar here when I run this program. So I'll do debug, and I'll just do, I'll run it. Okay. Well, you don't see it. But look what this say. What? What does this say?
Process has ended.
Program has ended, correct? Now, let's see something. Up here, I should have, where is it? I should have something called data.out. Oh yeah, it is there. Well, the data.out, I'm gonna have to show you where it is. put this back down there. The data.out is in the folder. So let me go to that folder. If I know where my folder is, let's see where my folder is. Is it on C drive or on D drive? I'm gonna have to check. Let's see. So when I go back, I'll go to download. I'll go here. Does it have visual? Might be C drive. Man, I think I'm gonna have to tell you what I'm gonna have to do. This is what I'm gonna have to do. I'm gonna have to go back. No project. All right. So it's user David source repos. Okay. All right. So here we go. So I'm gonna have to go to and it's let's see, users David source repo, and it's first program, and then look here, see this file here, test.out, I mean not test, data.out. When was it created? 7/7/2020. What time? 7:15. What time it is? 7:17. So this is my file. So if I double click on this file, and I'll say I'll open it up into Notepad, but it's just a text file, all right? I open it, and look what happened. Look my output. 1, 2, 3, 4, 5, 6 records, and then what? It outputted total and whatever my total was. So you see what happens? So I get my total. I didn't have to do anything. It didn't go to the screen. It went to what? It went to a data file. Everybody see that?
Mm-hmm.
Everybody see that? Anybody with any questions? Anybody with any questions? All right. And like I say, you might have a little issue, some little issues, because like I say, any little thing you click on, whatever, can cause you to go to the wrong path. But make sure you look at the how-to videos. Make sure you practice it, because like I say, this is getting into some of the way computer science is done. Like I say, read data from a file, writing data to a file, stuff like that. Once you kind of get to understand that, and you can really build on a lot of your programming skills. But you still got to learn all the other basics too. You know, you got to keep track with all the other stuff we're doing. All right. So what I'm gonna do, I'm gonna open that program up for you to be able to submit that one. So now, class, for this program, how many programs you gonna upload back to me? Hello?
4.
I'm gonna have 4. I'm gonna have the .cpp, the .h file, .txt, like I say, if you're gonna name your input file text.txt, and the .dat file if you're gonna name your data file whatever .dat. Everybody got that? Everybody understand? So you're gonna upload 4 different files. All right. So like I say, that's what this assignment says. You will notice that the program is exactly the same minus the code added to the output file. All right, test your program and remove all errors. Make sure you do that. And make sure that you check your output. Go to that data file, check your output. All right. Now, there is something you can do with your output also. You can give a path. Example, where am I? With Visual? All right, with Visual Studio, let me cancel it. In Visual Studio, I can actually do something like this. I don't normally do it, but you can do it. If I know that I wanted to put something on my C drive, or my D drive, I have a D drive on my computer, all right, or F drive, whatever. I could say D:, I'll do backslash, but I can't do 1. I have to do how many? 2, because remember, 2 backslashes is 1, right? And when you're doing folders, you're doing whatever. And if I had a folder that I was dealing with, I'll say backslash data. So what this means is I'm storing, I'm going to be reading text.txt from my D drive in the data folder, and in that data folder will be text.txt. All right, so you can do that. And even your output, you could do the same thing for your output. You could actually tell it D colon backslash data backslash, and it'll put it in the D drive in the data folder, and the file name will be created data.out. All right, so you can do that also. All right. All right. Now, so let me. Any questions? So let me add the. I never added the date.
I got a question. Does should online GDB give us a text upload that we can use?
You can give the name. I mean the name. You can specify the .txt name.
Okay, because yeah, usually once I hit like download, it gives me like the header, the main, and then that's what I usually upload. So it should
Right, but what I'm saying is, if you go to online GDB, you know how you can add file, or like add a new file.
Yes, sir.
When you do the header, you specify the name right then, like text.txt. You do it right then, and it's gonna be text.txt. You got it?
Okay. Yes, sir.
Yeah.
Thank you.
Right, and then that'll be your extension. Yeah. All right. Let me change these dates. The 14, 11, 59. All right. All right. So that's the assignment. So we got the assignment, and I can go ahead on. I'll publish the test, and all that stuff will be already published. I know the last time I published the test, I think I had the wrong date or something. So let's see. So edit this. Let's see. Yeah, 10 or 14. 10 o'clock. Well, hey, class, I'm gonna have to send an email too. Next class period, next week, we're probably gonna have to meet at 6, if y'all can, at 6 o'clock also, because man, I have another workshop they want me to do next week, man. Yeah. So if it's okay with everybody, we could do it. We could do it at that time.
Are you gonna post this class on YouTube?
I can't hear you.
The beginning.
Can we do what?
Are you gonna post this on YouTube? Because I missed the beginning. Okay.
Wait, say it again. I'll cut you off.
I missed the beginning of class. I forgot.
Okay, all right. I'll post, because I think I posted the last one. It was long, but
Yeah.
I went ahead and posted it. Yeah, but I'll post this one too. Yeah.
Okay.
But and like I say, you have also the notes from the other one, but this one will be more familiar. You know pretty much where to fast forward or whatever because we're going through it. But like I say, you're welcome to look at the other notes too, which gonna have some of the same instructions and whatnot in it. All right.
Okay.
But I'll post it. Okay, 10 a.m. All right. Oh, well, I could give you, well, I'll tell you what, because we won't have class till 6 o'clock. I'll send it at 5. But make sure you take the test for class. Yeah, all right. Okay, all right. Okay, so that, and I got July 11th. No, yeah, 11th. What's the 11th? No, not the 11th. Change that. All right. Okay. So yeah, so that's saved. So now let's look at the notes. All right. And where we are. Let's see. Anybody with any questions? Questions? All right. So let's see. Let's go to the chapter. Well, I'm gonna have to scroll down. Chapter 5. Here we go. So this is the chapter 5. At the end of the chapter. 5.6. And we're dealing with loops. All right, here we go. All right. All right. There we go. Here we go. All right. So now, what I'm going to introduce you to is the plus plus and the minus minus. All right. Good operators, but you got to know when and how to use them. All right. Plus plus, minus minus. But then we also have the plus equal, the minus equal. We talked about those, I think, in the last chapter. So, plus plus, all it simply does is add or increments a variable by 1. All right. If it's equal to 5, if x is equal to 5 and you do x plus plus, that means you want to add 1 to x. If x is 5 and you do x minus minus, that means you want to take away 1 from x. All right. And for any other variable that you have. So, what's the big deal if that's the case? Well, the big deal is this: when it's done and why. All right. What happens is, and I'm gonna take this out. We didn't did this, so I could take this out. I'll take this out. And I'll show you a little something. All right. So what happens is, plus plus. You can also do plus plus x or minus minus x. You know, rather than x minus minus. So I'm gonna do this, and I'm gonna say plus plus x. X plus plus. All right. So the difference in these two, the x plus plus will increment x on that line at that time. The x plus plus will increment x after it leaves that line. Well, you say, well, what that mean, Mr. Sylvester? Let's look at this. I'll say int y is equal to 5, x is equal to 4. Now, I'll say y is equal to y plus x. So, all right, so class, given this little small program, that's x, I put a semicolon, comma. All right, so given this small program, okay, y is 5, x is 4. Y plus x is what? Class, what's y plus x?
9.
5, y plus x is 9, but y plus x is? Hello? Anybody? Educated guess.
1.
How many?
1.
Y is equal to what?
5.
All right. X is equal to what?
4.
4. So 5 and 4 is what?
9.
But what am I doing on that line? I'm adding what?
Y.
I'm adding 1 to what?
Y.
No, well, 1 to x. I'm adding 1 to x. As a prefix. I'm adding 1 to x and then adding it to y. So what that's going to equal to?
10.
10, correct. 10. Pre. That means whatever. If you see a plus before you see that variable, you got to perform that operation before you do anything to that variable. So therefore, X on that line turns into 5. You got what I'm saying? Before I process anything. So that means 5 plus 4 plus 1 gives me 10, right? So let's run that and see if we correct. Where's my, let me see my output. Not this, I close this. All right, so look here. What Y equal to?
10.
Everybody see that? Y is equal to 10. So let me add a new line at the end just to make sure they take this down. All right, everybody understand what just happened?
Mm-hmm.
I'm gonna run it again. So like I say, let you see it. All right. Y is equal to 10. 5 plus 4 plus 1. Everybody got that?
Mm-hmm.
Which is equal to 10. Now, you say, well, Mr. Vessel, what's the big deal? Okay, look at this. Now what happens? So what the value of Y going to output this time?
11.
Huh?
5 plus 10.
Okay, why 10?
Because X plus 1 plus 4. Well, 5 plus 1 plus 4.
Well, 5 plus 1 plus 4 is equal to what?
10.
But that's not right. This is what happens. Remember I said if it's prior to the variable, you have to perform the addition before you do the equation. But if it's after, it will not perform the increment or decrement until after it leaves that line. So anything I do on this line at this time, the plus does not take effect until I move to the next line. So what Y should equal to? This is 5, right?
Uh-huh.
This is what?
4.
4. This does not change to 5 until it goes to the next line. So Y will equal to?
9.
9, right. Everybody see that? I don't want this. But everybody see that? Y is equal to 9, right? 5 plus 4. Now, I'm going to show you this. You say, well, Mrs. Avesta, but you're saying X is changing. X must not be changing. Okay, what we're going to do here, we're going to do this. We're going to take this and we're going to say, now, so I'll change this back to plus X, right? Oh, if I could type. So at this time, what will Y be? Y will be what? Looking at this expression.
5.
Y will be 10.
10.
Y will be 10. 5 plus, but I got to do all of this first. 1 plus 4 is 5, so 5 and 5 is 10. Now, what will it output for X? What is X? What will output for X? We know what 10 gonna print here. What's gonna print for X?
Is it 4?
4.
No,
Yeah.
we increment it to get Y, so it's equal to what?
It's equal to 5.
5. So let's run it. Let's debug. Let's see. Let's run it. Let's see. Wow, x is equal to 5, right? Everybody got that. Now, let's go back to the other one. Let's do this. And I'm trying to just kind of making you see what's going on. All right? Because you can get confused. Now, what will y be this time? Huh?
9.
9, because what? 5 plus what? 4. This is pre-post, so we don't do anything until we leave the line. So 5 plus 4 is 9. So 9 will print here, but what's going to print here?
4.
Huh?
4.
When did we say x change? When does x change?
In the end?
As soon as we leave that line. So we done left the line. So on this line, x is what?
Oh, 5.
5. So watch. So let's look at it. See, x is 5. But everybody understand what I'm trying to get you to understand. The plus plus and minus minus will always increment x, right? But if it's pre, it's going to perform it on that line to solve the problem. If it's post, it will use the original value and then increment as it goes to the next line. All right? Everybody got it?
Yes, sir.
All right, so let me do this then. Let me do this. Okay, so what's y?
9.
You got what?
The line.
This is what? I tell you, well, should I leave this as y? Because it's affecting that. I'm gonna change it to, well, I'll leave it because this gonna stay 5, right?
Mm-hmm.
Because this is post, correct?
Yeah.
This gonna stay what? 4.
Oh, 4.
Because it's post, right? So 5 and 4 is what?
9.
Huh?
9.
It's 9. But now I'm figuring out once it put 9, it might go to 8 because we got minus because it's the same variable. I'm kind of shaky on that. We'll see. But it should be 9 to solve it. See? And it went to 8 because what? Once we solved it, we had to do a minus on the whole thing to reduce it to what? 1 more. You got what I'm saying?
Mm-hmm.
As it solved this is a minus. So whatever y was at this point, there's a minus here, and it reduced it by 1. Everybody see that? It used the 5 to solve the equation, and the 4 to get what? 9. But then you got a minus, and that makes it what? When this came to the next line, y became 8 because the minus. Because it left that line. It only going to perform it after it leaves what? That line. All right? And like I say, this stuff gonna come into fruition when you start looking at the loops that we're talking about. All right? But you need to understand that, how that works. Only after with post. But if I do something like this and take this off, then all of a sudden, what's y? What's the value of y gonna be? 6, right? Plus 4, right? Gonna give you what? 10, right? Right, Claire?
Right.
Do the pre, do the post, all right? And you're gonna get 10. All right. Now, okay, so let's look at our loops. Like I say, we had plus equal. We know that plus equal allows us to to take a value and add. So if I do y plus equal x, what's that saying? What's the value of y going to be?
9.
This is the same thing as saying y equal y plus x. So what? Yeah. So you said the answer is what? 9, right?
9.
Right. If I did this, minus equal, what that answer?
They do negative?
Right. So that's just like saying y is equal to y minus x.
So 1 or is it negative 1?
It'd be what?
1.
1, because what? 5 minus 4, you get 1, right?
Do they do negative?
No, the negative tells you what to do. You understand?
Yeah, but if it was 4 minus 5, can you do negative or does it have to be like?
Oh yeah, you can't get a negative because look, if this was 24, right?
Mm-hmm.
Then you would get a negative number.
If you do.
See? You understand?
Yeah.
So you can get a negative number because that negative was higher than the positive, right? Now, what about this? Did I answer your question?
Yeah.
Okay. What about this? Oh, if I could type. What about this? What's y equal to?
5 times 24 or 4?
Huh?
5 times 24 or 5 times 4?
What you say? 5 times what?
24.
Oh, whoa. Yeah, let me change that to 4. All right, so what that answer is?
20.
Huh?
20.
20, right. So y is equal to x time y. I mean, y is equal to y times x. Now, what if I do this? This is it.
1.25.
Huh?
1.25.
That's it.
1.
Right, you understand?
Mm-hmm.
You get 1, right? Y is equal to y divided by x. How many times x go into 4 go into 5? 1 time. Don't have no decimal place, no nothing. It's just 1. Right? It just should give you 1. Right. Got me? And like I said, we have to look at that data type, correct?
Uh-huh.
All right. So now, so we got those out the way. Let's go back to the notes. So we should kind of be familiar with that. Minus equal, plus equal. So that's both prefix, postfix. You could look at that. That tells you basically what we just did with those programs. All right. So that's what all this doing. Telling you how to use the pre and the post and what happens, when it happens, etc. All right. Now, this is an error. You cannot do stuff like this. All right. But you can use it in an expression like this. All right. But you can't do this. All right. Because that's a collective group of numbers. All right. So now, loops, the while loop. The while loop allows you to perform something multiple times, but you, the user, have to set up that loop. Now, the while loop is set up in a fashion to where something has to be proven true before it can fall into it. But like I say, I got x equal y equal 5, x equal 4. So and let me do z equal let's see, z equals 0. I'll do that. So I'll do something like this. While this is the format, and your expression would go inside here, whatever your test condition is, and then you can have one statement, or then normally you have to have multiple. This is your group of statements. This is the block that you want to perform if this is true. So I could say here, while z, if I could type, while z is greater than or equal to 0. Okay? That's my test condition. Now, I got a semicolon. So class, if Z was 20, would it ever fall into that while loop?
Mm-hmm.
Well, no, it would, right? It would. So I wanna change that. But if Z was a -5, would it fall into that while loop?
No.
Huh?
No.
It's right, because -5 is not greater than or equal to 0. So what I'll change this while Z is less than, and I'm gonna do while Z is less than 5. Now, so Z is 0. So looking at that, now I'm trying to create a loop to where Z can go from what? What's my starting point for Z? 0, right?
Mm-hmm.
And then I'm gonna go to less than 5. So how many times it look like I'm trying to perform that loop?
5 times.
5 times. 0, 1, 2, 3, 4. Kick out at 5. You understand? So you see, but Z has to be less than 0 for me to even fall into this loop. If Z was 10, I could never fall into here and do anything. So now, in here, I'll just do something like C out, and I'll say, if I could type, /T BRCC, all right? All right, so I'm gonna print out BRCC, go to a new line. So I wanna do that for 5 times. Now, I'm almost finished. I got a condition set up here where it allows me to fall in the loop. I got my condition set to where I can fall in the loop, and I have my limit at 5, and I'm gonna print this. But I have a problem. Who could tell me what my problem is at this point with this loop? Who could tell me my problem? I'm gonna just change this. Don't worry about me doing this. What is my problem with this loop? Okay, let's do this. What is Z equal to the first time?
0.
All right, is 0 less than 5?
Yes.
Okay, I'm gonna output what?
BRCC.
Okay, I'm going back, go back, check again. What is Z?
Z is 0.
Is 0 less than 5?
Yes.
What I'm gonna do?
Print out BRCC.
All right, go back down here. Oh, come back up. What's Z?
It's 0.
Is 0 less than 5?
Yes.
What I'm gonna do?
BRCC.
Does anybody see a pattern here?
Yeah.
You're in a
Well, how am I
continuous
supposed to
loop.
do that?
Right, I'm in a continuous loop. I never set my program, my loop up to where Z is incrementing so that I can what? Try to reach what? The 5. So
Right.
how can I do that? What would I need to do inside this loop to increment my Z?
You can.
If else.
Huh?
If else.
I can't hear you.
An if else statement.
If else, why if else? All I want to do is increment my Z.
If it is more than 5,
But that's right here.
and then in the else in the program. 'Cause it's
Okay. All right, let me show you something. What about this? Would that work? Let's test it. Was Z the first time through?
0.
All right, is 0 less than 5?
Yeah.
What we gonna do?
Print out BRCC.
And then what we gonna do?
Add 1.
Which with Z becomes what?
1, 2.
Okay, is 1 less than 5?
Yeah.
Okay, what we gonna do?
Print out BRCC.
Then we gonna do what?
Add 1.
Which is?
2.
All right, is 2 less than 5?
Yeah.
Okay, then we gonna do what?
Print out BRCC.
Then do what?
Add 1.
Which become what?
3.
Is 3 less than 5?
Yep.
We're going to do what?
Print out BRCC.
Then do what?
Add 1.
Which become what?
4.
Is 4 less than 5?
Yeah.
And we do what?
Print out BRCC.
Then we do what?
Add 1.
And then what? 5? Is 5 less than 5?
No.
All right, so we're going to do what?
See out.
Right, see out there, right? So you see what we had to do with that while loop? We had to create some kind of increment to what? Try to reach that value. So let's run the program. We went through it physically, but let's run the program and see what happens, all right? Bam, you see? BRCC, 1, when Z, I could print out Z, but it's 0, 1, 2, 3, 4, it becomes 5, it kicks out, right? So what I'll do, watch, I'll do this. I'll do something like, this. So you'll see what happens, because the first time through, it's gonna print out 0. So let's run it, let's build, let's debug it. So, I'm printing out X. I want to print out Z. And that does happen too in programming. You have the wrong variable and you're trying to change something and you're changing something that mess up the program. So I'm printing out X when I should be printing out Z. All right, so here we go. X is 0, X is 1, Z is 0, Z is 1, Z is 2, 0 is 3, 0 is 4. But when 0 gets to 5, it kicks out and it prints out program is complete. But everybody see what happens. I have to have a value outside of the loop to say what? Hey, fall into this loop. I have for this condition to be true. You know, so 0 was less than 5. It fell into the loop. And now, how many times I perform it? Oh, it depends on this starting point and this range here. And then I'll perform it until whatever, and then kick out, right? Now, what I'm gonna do, I'm gonna comment this out. Remember we said, Mr. Steak Spooner said, infinite loop. If we never execute Z++, then you got an infinite loop. Your program just gonna continue running and you weren't wondering, what's going on, what's happening? Because see, Z staying at 0, your program just gonna continue to print out BRCC, until it times out. But everybody see what's happening. Only because I'm not incrementing to get to that 5, all right? Okay, so I'll never reach that 5. So that's that. Now, but class, just like you increment, you could decrement, because what? I could set Z to equal to 5, and I could set Z greater than 0. But what do I have to do in my within here to make this work? Anybody?
Doesn't it already work?
Huh?
It's not gonna, because Z is more than it. Oh, yeah. Oh, you have to put it is right.
Huh? It's correct? I don't have to do anything?
No, because
I don't have to do anything here?
oh, you have to do minus?
Ah, right, because I need to go from what? 5 to greater than 0. So I'll do what? Minus now. You got me?
Yeah.
And what I'm saying is some people think forward, some people think back. And when I'm saying backwards, going from high to low. Which one is right? Long as you perform the loop, X number of times that you need it is correct, right? So let's run it and see how many times it will perform. All right, so we debug it. All right, so this time we're gonna go from what? 5, 4, 3, 2, 1. 5 times. So either way we went, we still went what? 5 iterations, which is what we wanted to do. So like I say, when you writing code, many times people might write different from you, but they're trying to accomplish the same goal. All right? So anybody have any issues or questions with the while loop? All right? Know how to set it up. Now, this is the thing. The while loop, well, let's go back to the notes because they might have some information that you might want to know. All right. So with that while loop, here it tells you if falling in is true, and as long as this expression is true, it's going to perform those statements, check, perform, check, perform, check, perform. Soon as this is expression yields false, then it'll continue on with the program. That's the while. And look, this is the example. It shows you the format, while, whatever your expression is, and then whatever statement's in here. Now, with that while loop, as I said, you have to try to get to that value. You can't just let your program continuously run a loop. You know, your program just gonna be stuck. So look here, this is a program similar to what we did. We just printed out BRCC. They set number equal to 0. They said while number less than 5. We had while z is less than 5. We outputted BRCC. They outputted hello. Then what? The value that they're comparing, which is number, which is starting at 0, what they did, they incremented by 1. So each time through that loop, num start at 0, increment by 1, num is 1, increment by 1, num is 2, increment by 1, num is 3, increment by 1, num is 4, increment by 1, num is 5, it kicks out. That's all. All right? Simple program, but I want you to understand that logic, understand how that logic works. All right? And then it tells you why you do the while, and then the body of the while loop. Okay? Now, you can have as many statements as you want inside that while body. You can even have if statements. You can have other type loops inside that while loop. All right? So you're not limited to any type statement. You can have any valid C++ statements within that while loop. Okay? All right. So it tells us that a while loop, like I said, is a pretest loop, meaning that what? Until that this holds true, you will not perform any statements inside this while loop. You have to be able to, this has to yield true in order for you to fall into here. The num equaling to 6 or greater will never allow you to print the word hello. Never. Because it's going to just continue on, fall over that and continue on with the program. All right? But anything less than 5, if number is less than 5, it'll allow you to go into here and then perform until you get to the limit of 5. All right? So this is the format. Now, this is one problem. Normally, it's not an error. You don't get an error. Sometimes you may get it, but most times you won't. So like here, if I put that semicolon here, see, I don't get an error. But what happens is, how many times will I print out BRCC with that semicolon at the end of the while statement? Huh, class? How many times you think it's gonna print, or will it print out anything?
No.
Anybody?
No.
How many times?
0.
What you say? 0?
Yeah.
All right. Anybody else? All right. Let's go through the program. Okay. It says, okay, Y is 5, X is 4, Z is 5. Okay. While Z is greater than 0, is 5 greater than 0?
Mm-hmm.
So now,
Yes.
what I'm doing here with this semicolon, though, I'm saying I'm ending my while loop. Everybody got that? Everybody hear what I just said?
Yes, sir.
I'm ending my while loop. So what happened to these statements? This just become common C++ statements. So I just go on and continue to perform these statements. So what's gonna happen?
It's going to say program is complete.
I can't hear you.
Program is complete. It's going to put that out.
No, because what? This is just in curly braces. It's not a part of the while. The while ended at the semicolon.
So it's just going to do it once.
Right, as if it's just some plain statements in the program. So it's gonna print C out, it's gonna C out BRCC and whatever Z is, which is 0. It's gonna increment Z, and then it's gonna print out program is complete, and it's finished. And you're gonna be like, what's wrong with my program? Oh, Z is 5. It should do this 5 times. So what's happening? And I'm gonna tell you, it's gonna happen. And it's gonna be somebody walk back by you and you show them their program and be like, you got a semicolon. And sometimes it's hard to find because you're not thinking that you would put a semicolon there. You're like, okay, I know I didn't do that. Oh, it's not, that's not how to write a program, but you've done it, So where's the output? Where is the output? Huh. Let me see. So let's run it. What's going on? Debug, run.
The semicolon's still there.
What I'm doing? I'm doing debug or something. No, where is it? Nope, it's not doing anything, but why?
Is the semicolon still supposed to be there?
Oh, that's what's happening. Class, I'm wrong. No, the semicolon not supposed to be there. But what it's doing is it's performing this, right? So what is Z at this point? What is Z when it gets here?
Z is 5.
Does that make this true?
Yeah.
5 is greater than 0. So when do I ever leave here? When do I ever increment Z? So what's happening? So what I'm doing, I'm in
an infinite loop.
I'm in an infinite loop. So I'm not even moving on to perform the rest of them. Everybody see that? So I was wrong on that part. It stopped here and it just continuously just stayed in this loop and just say, okay, Z is 0, okay, Z is 0, Z is 0. I mean, Z is 5, Z is 5, Z is 5, Z is 5. So it never got out of that. And that's all because of what? That semicolon. So the book says it's an error, which is an error, but it's like a programming style error. It's not an error, a syntax error that you're gonna get. The program gonna say, okay, well, I'll take that. If this is what you want the while to be, I'll take that, and then it'll run it, but you'll have that infinite loop. All right. So you gotta watch that. Don't stop your while loop by putting a semicolon here. All of this is a part of your while loop. All right. Everybody got that? Okay. So now. So like I said, you run the program and whatever. It said don't forget the braces. Remember we talked about those curly braces? And with the if statement, if you want to perform a block of statements, put them in the curly braces. Anything else that you don't want in the part of that goes outside of the curly braces. So, but all that you want to perform, if in that while, make sure they are a part of the curly braces. They talk again about programming style. Like I said, you can write code this way, but that's, I wouldn't say confusing. It can be confusing, but you can run into problems trying to find errors because all this is one line number, all of this, okay? All right, so now, we talked about the while loop. Now, remember we talked about and or? Everybody, remember we talked about and or on last class period. So now look, just like you use and or in with an if statement, you could do the same thing with a while statement. If I told you to write a program that will convert the temperature that will allow you to input a Fahrenheit temperature between from 25 to 50 and convert it to Celsius, then you would have a input statement to input a value, and then you would have maybe a while statement to say, while whatever is less than whatever, give me the Celsius value for each one of those. If I wanted you to do the increments from the value you give me on to 50, right? But that you can use and or. So like you say, while number is less than 1 or number greater than 100, all right? So that means you're using a range from 1 to 99, all right? So you can use the and the or. You can compound them to be larger than one and one or, and you can use your braces, all right? So that same concept that you use with the if statements, with and or, you can do the same thing with your while statements, all right? And even your do while. Well, the while gonna be a while, all right? Counters, all right? Remember we had that Z in our program, Z++? That's like the counter. That's the thing that's gonna allow us to increment to get to our value. Most programmers, what they'll do if they know a certain number is a consistent number for a loop or something, they'll make it constant. And then what they'll do is they'll say, okay, constant max value. And so when they do a loop, they'll say, while whatever is less than max value. So they don't have to try to keep typing in the exact same number over and over and over again. They have it as a constant, all right? So that's all they pretty much did in this one. And let's see what max value here. I'm covering it up. All right. So see, they got constant, min num, and then max num. So they know they're gonna always start at 1 and then do greater than or equal to, less than or equal to 10. All right. So they knew what they wanted. So every time they're running something, they know they're starting at 1, doing less than or equal to the max number. So that's just some little programming tips that you can use. But you always can put in your values from this number to this number, 0 to 5, -5 to 0, whatever it is you do. Now, the do while. The do while is just like the while, but with the do, you do not have to test first. You test after you execute statements. So what that means is you will perform the process or the body of that loop at least one time, then you test. Give an example. To change this program to a do while, I would take this information here and move it here. And all I would do up here is put do. But there's one other thing I need to do. I need to put a semicolon at the end of the while. So do this and put the semicolon here to end that do while. So see how it's a little different? The while loop, you don't put that semicolon at the end. You don't even use a semicolon in the body. But with the do while, you would actually say do, have the body, and then right at the end of the body, you'll put the while statement and the semicolon. Exact same logic. Everybody see that? But the good thing, the thing is about this one, it will automatically execute this one time. It will automatically output BRCC. So let's output this with the given information, and we should get the same results as we got previously. All right? 5 times, right? 5, 4, 3, 2, 1. Everybody see that? But now, let's do this. Let's change Z and make Z equal to 15. Well, let's see. While it's greater than 0. Let's make it -5. So if Z is -5, right? Is -5 greater than 0?
No.
Right. But will it perform this? Will it perform this information here?
Yeah.
It says yes. It says do this. Only check after you do this. You got what I'm saying? And if it's not, then you're gonna kick out and continue. So with it anything less than 0 or 0 or less, it's gonna print it only one time and kick out. So watch.
Stop at the semicolon.
You need the semicolon.
Okay.
See? So it printed it out one time. It was -5. -5 wasn't greater than 0, and then it ended. Yeah, see, this a do while. You understand? This says do, and then what you want to do, I want to do from this to this, but you would need the semicolon at the end of a do while. But if I had a while up here, and I had a curly brace here and here to complete it, I wouldn't need this semicolon. You got it? You got it?
Yeah.
Huh?
Yeah.
Oh, okay, all right. Because I'm saying it'll give you fits. I'm telling you. So everybody understand with the do. Now, with the do, I still have to do what? Either my increment or my decrement, correct? Because what? I have to try to get to what? To z less than 0. You got what I'm saying? If I don't, I'll still be in an infinite loop. Because if I did this and I put plus plus, I could still be in a what?
Do for a while.
Infinite loop, because I'm going from 5 to plus infinity. And really I'm trying to get to what? 0, which is going toward the negative side of the number line, right? So this would give me an infinite loop. So I can still have an infinite loop with a do while. See here? So I'm still going up. I'm not going down to 0. I'm going up. You see how Z keep changing? Z is just incrementing, but it never getting to the -5 to the 0. Okay, so I could still have an infinite loop. All right. Let me fix my window right here. All right. Okay. So now that's the do while. So let's see what else the book say about the do while. All right. But it's still talking about the while. Well, it's basically the same. What we just talked about. You got int x = 1, while x is greater than 0. All right. 1 is greater than 0. See how that? But the only thing with this one, this is an infinite loop because what? Let's see. While x is less than 0, it won't fall into here. So because 1 is not less than 0, it will not perform this. But with this do while, int x = 1, then do this, it will perform this, but when it gets to this, then it will kick out. Now, you're looking at this and you say, well, Mr. Vessel, where's the curly braces? Remember what we said about the if statement? If you got only one statement to execute, they're not needed, correct? But I would say it makes for confusing code when you start adding statements. So I would always curly brace, curly brace, curly brace, curly brace, just to keep it uniform. And when you start adding, you know that this is gonna go with my while loop. This is gonna go with my do while loop. And you're not forgetting to do it and you're running into problems, all right? But it's okay, you can do it. Look at this while loop. If again is equal to y or again equal to lowercase y. So see, they use the or operator in here to where they checking to see if that choice that they're inputting, that character value is equal to an uppercase y or a lowercase y. Now, remember your program I gave you. I gave you a program to input 3 values. You're going to input the first one, input the second one, input the third one, calculate an average. Then what? Do you want the average another set? Now, you're not going to be doing the average for another set, but you're going to be doing, oh, yes, you will. You will do the average because I asked you to do the average of 3 numbers. So basically, this program is somewhat what you need to do. You understand? But like I say, here it's showing you what you could do it using a do while. Yep. Or if you know how to use the while, you could use the while. You know, but either one. But the thing is here, you could use this do here. All right. So this one does the do, and you could keep on doing it, keep on doing it, keep on doing it. But when you're doing those 3 values on the inside, I want that in a loop too. So that you gotta go have a loop within a loop, right? So you have to determine which loops you want to use, but that's gonna be up to you, all right? But that's the do while, and it tells you that do whiles are good for menus. And what that means is, just like you have, well, let's say, look at this. See, like this here, they got do and they got open curly brace. That's where it starts, and it stops further down. Let me see if I can change my view. It's one of those scrolls, 2-page scroll. I think that, no, I don't want that. View. Enable scroll. All right, so here. So what happens here is you got to do here, right? And then, it goes all the way to the end, okay? And there's the while. So you're doing all this within this do, all right? But then in here, you got a menu that you're displaying. See how this, and a choice. And based on your choice, then you got a while. While the choice, if the choice is 1 for adult membership, because see what happens is they did a constant value. Adult choice is equal to 1. So that's why they can ask if adult choice is equal to quit choice. See, quit choice, not quit choice, choice, right? So, and choice greater than quit choice, right? So here we go where, not here, right? So if adult choice, while choice, okay, number 1 is less than adult choice, 1 is less than adult choice, or choice, which is 1, greater than quit choice, which is all both invalid. Please enter a value in the range of 1 to 4, really what they're saying. But if you enter the 1, if choice, which is 1, is equal to quit choice, which was 4, then you would quit and then you finish. But if it was not that, then you got switch choice. If it's 1, you're doing the charges for the adult. Break, remember we talked about that break. Then case, choice, kid choice, which is 2, you're doing this. Break, but then if it's not that, then you're doing the choice for the other one, for seniors, which is 3, and you're doing that, right? And then you're displaying whatever charge you calculated, and then again, while choice is not equal to quit choice, you're going back over here and doing the do again, and you're actually displaying the screen, and then you asking what choice, and whatever choice they put in is gonna say it's invalid, or they're gonna continue again. So this is a small program with that with a continuous loop. Like here, the first time they put in 1, they calculate, ask for how many months, then they calculate the total for an adult. Next time it asks them if they want it, well, it displayed the thing again, asks them the choice, they input it 4, and they exit it. All right, so that's a loop. That's dealing with a loop with a menu. Okay, now the for loop, and that for loop, what the for loop does, it gives you can initialize it or you don't, a value, the test condition, and your increment or decrement of your variable, update to update it. So let's look back at this. Now, what was that? Oh, no, what this? All right, so let's look at this. With this loop, we know we wanted to do it, what, 5 times? Everybody understand that, right? So what I can do, I could take this off. because I know I wanted to do it 5 times. Now, I could do something like this. For int z equals 0, even though I got it initialized at the top to 5, this is a new scope, but I'll just take it off here because I'm using it up there. All right. So int z equals 0, z less than 5, z plus plus. Now, I need to take that semicolon off. Now, so looking at this, I'm starting, what's my starting point? My starting point is 0. Z is 0. It's testing to see if z is less than 5. So as long as z is 0, 1, 2, 3, 4, I'm all right. All right. Then I'm doing what? Z plus plus. So when I leave here, z is 0, it performed this. Z is 1, perform this. 0, 2. But look at this. I'm going to just comment. Well, I'm going to take it out. I'm going to take it out. And I'm going to show you why. All right. So now, this will perform output BRCC 5 times, starting at 0, ending at 4. So let's run it. So it's going to do just exactly like that while loop did previously. See? 0, 1, 2, 3, 4. Program is complete. So you got the while loop, you got the do while loop, and you got the for loop. Now, look at this, class. We said if we can have an infinite loop when we're dealing with loops. You can say, well, okay, well, Mrs. Lester, how can we have an infinite loop with a for loop? And we got the starting point, we got the increment, and we checking to see if it's this. Okay, simply by doing this. What happens when I do that, class? If I put z minus minus inside of this loop, what am I doing?
Subtracting z.
I'm negating my increment for z. So z will always be what?
0.
0. Z will always be 0. So when I do the debug, see what I'm saying? So I can get an infinite loop if I forget to leave one of those increments or decrements in my program in that loop, depending on if I'm incrementing or decrement. So now I'll take it out. Well, you know, if I take it out, it'll work. But then look, I could do this too. This can be a logical problem too. If I told you to write this program, right? Take this program and look at it, run it, but I only want I want BRCC to print 5 times, and I have this in the program, and I want you to fix it. So if I run this program now, how many times are going to print out BRCC? How many times are going to print out BRCC?
Forever, because
what?
z is more. Oh, z is less than 5. So no. Until it becomes 5. So 5 times, yeah, 5.
How many times?
5.
Okay. What's the starting point?
0.
0.
All right. We outputting BRCC, right?
Mm-hmm.
That's 1 time. We increment z. Z becomes what?
1.
Then z becomes?
2.
All right. Is 2 less than 1? Less than 5?
Oh no.
Is it?
Yeah.
Yes. So we're gonna print out what? BRCC, right?
Yeah.
So that's 2 times. Then what? Z becomes what?
4.
3, right? It becomes 3 here, and then it becomes 4 here. Is 4 less than 5?
Yeah.
So it's gonna print, right?
Mhm.
Then this become what? Z becomes what?
6.
5. And then when it get here, it becomes what? 6, right? Is 6 less than 5?
No.
Oh.
No. So how many times is it going to print BRCC?
3?
3 times. Because we doubling up, right? We're doing 0, 1, 2, 3, 4. You got what I'm saying? We doubling up on the adding of increments of Z. And then let's look at the output. So you see how you as the programmer, sometimes your logic, you got to be able to look through it. You got to be able to know what's going on, because those simple increments can cause havoc. You wonder, well, why I'm not getting this record? Or say you it could be dealing with you personally. Like say a company is putting your records together or calculating your pay, and all of a sudden a programmer did not write the code where all your records are lined together, and you got paid somebody else paid, which is considerably less than yours, and you saying, well, wait a minute, what happened here, right? So all those numbers and everything got to match. So, and you have to, as a programmer, have to know what's going on in the program in order so that you can fix it. All right. So now let me ask you this. That's increment by 1. What if I do this? What happens now? How many times am I going to print out BRCC?
Yeah.
Huh?
Three times.
How many?
Only once.
Maybe twice, right? The first time Z is 0, right?
Yes.
Then it's going to increment to 2. Then it's going to increment to 3, right?
Yes, sir.
So 3 is less than 5, it's going to print. So now it's printed twice.
Oh.
So 3 and 2 is what? 5 plus 1 is 6. It kicks out. Right?
Okay. Yes, sir.
Everybody see that. And the output should show you 2. You see? 0, and then we added 2, and then we added 1, and made 3. It printed. Then we added 2, made it 5. Then we added 1, made it 6. Kicked out. Right?
Yeah.
So like I said, you got to be careful. You got to be wise to how you're writing your code. But that's a for loop. And look, a for loop, I could do this. Okay, I want to print out BRCC. If I wanted to print out BRCC 50 times, what I need to do?
Bring the number up.
Huh?
Bring the number up.
What?
The 5, the Y.
What I need to do?
Change 5 to a bigger number.
So a bigger number, what that bigger number is? I want to print BRCC 50 times.
10.
10?
Oh, no. 50.
It's 50. I'm going to go from 0 to 49, right?
Yeah.
Right. So you see how that for loop, if you know the count or how many times you want to iterate, then you can use a for loop. But if you have something where you don't know exactly how many times you want to perform it, like somebody have to put in yes or no or something, then you can use a what? A while loop, right? So see the difference in the 2 loops? One of them, this one can do a particular count, right? Which the while loop can, but the for loop is kind of built better for that. But in the while loop, you can do it to where you can do it forever until you're ready to kick out. All right. So here we go. This is see 50 times 0 to 49 is 50. See the 0 have to be added as 1. All right. So everybody see that. So with a count, you can always set it to what you want. All right. So that's the for loop. Now. And like I say, look, for, this is your value and your variable. Now you can have count initialized or declared previously in the program, or you can introduce it new. Int count equals 0, count less than 5, count plus plus. And all these are separated by a semicolon. All right. And now, like I say, I would put the curly braces. You don't have to, but man, I would put the curly braces. All right. And then just telling you how it stepped through. It actually set the value, test the test condition, and then your increment or decrement, depending on which one you use. All right. Question. Now, this is a program. This is one of the programs I think I got y'all to type up when with the beginning of the semester, dealing with a for loop for min number to max number, and whatever number they put in, it's gonna loop until that number to give you the square of that number. All right. So that's all that program is. All right. Now you can have nested loops. Nested loops can be very, very confusing. All right. This still talking about the while, but like I say, the while part, we got num. Okay, num less than equal to max. You got to have a condition here. Then inside of here, you got to increment this value to try to reach this. Whether you're going the negative way or the positive way, you got to try to reach that value. Otherwise, you're going to be in an infinite loop. All right. A for loop is a pre-test loop. All right. So it's like it's setting it to equal to this less than equal to this, and then perform this. All right. It says avoid modifying a counter variable in the body of the loop. We talked about that, remember? This doubles it up, right? Or if we have the negative, it negates the plus here and puts you in an infinite loop. So be aware of that, all right? So you got to watch it. Now, look, it tells you can step up by 2 if you want to. That's valid, you know? But like I say, normally when the code that we give you, we normally incrementing by 1 because we trying to get you to kind of understand the iterations and whatnot. But you can, if you have to, double up and move step by 2 or whatever. All right. Yeah, that's still the squared one, and like I said, I think they kind of wrote it up a different way, you know, with the for loop. Multiple statements initialized. All right. Well, all it's showing here is like I could introduce new variables in here, as many as I want. For int, for x equal 1, y equal 1, x equals whatever, and then I can do whatever. I introduce them inside the for loop, no problem. All right. So and it ain't no big deal. But like I say, we don't normally code that way, but you can code that way. Now, this part here, let's see where it is. Yeah, that for loop, look at this statement here. No, or they just talking about the same thing. Omitting the loop expression. For, and like I say, you know what num is, and then num less than max value, num plus plus. So what? I don't have to reintroduce num or say for num equal 1 because it's what? It's already known. It'll grab that value and it'll continue. You can do that, but like I say, for safekeeping, now the time you want to put that value in there because you want to know where you're starting from, because this initialization just sometime might be 10 lines down from that, and you got to go back and try to find and figure out where it's initialized in the program. But it's not an error, it's not a problem. You know, it's all in your programming style. All right, all in your programming style. All right, now very close. Keeping a running total. Now that's that other thing where we had plus equal, minus equal, or whatever, but we had like x is equal to x plus 1. That's where you're getting that running total. Every time you're going to add to x, you're adding whatever x already is to whatever that value is on the other side. That's what they talk about, keeping a running total. And I think in your loop, when I gave you to add those 3 values, you got to accumulate those, the average. You got to accumulate those numbers. Once you get outside, calculate the average. So you got to add them to, like, total is equal to total plus num. All right. It's on both sides of the equal sign. See, total plus equal sales. That's just like saying total is equal to total plus sales. So each time you're accumulating totals, keep adding to it. All right. So it tells you about that. A sentinel value. And a sentinel value is just a special value that allows you to control a loop or whatnot, or either in a read of a data file, or either to terminate a loop. Like you might have, please enter a value or press QQ to quit. So QQ would be your sentinel value. You know, so until that loop sees QQ, it'll continue to perform and do whatever it needs to do. So that would be a sentinel value. All right. What else? All right. Deciding on which loop to use. Remember, I think the first program I gave you, I told you, given the 3 programs, decide which 2 you want to use to do what you needed to do. Now, the 2 you use, you're going to use a nested process. And you say, well, Mrs. Vessel, what is that? Why would that be? What that is something like this. So here I have, for z is equal to 0, I'll say z is less than 3. All right, I'll put 3. Now, and then I could do something like this, C out. If I could type. All right, so I'll do this. Okay, and then I'll do C and num. I'll do so equals 0. C and num. All right, so what this does, this is gonna allow me to enter 3 values each time. But outside of that, I could do something like this. All right, I gotta use double equal. Yeah, that's another thing. Remember the double and single equal? The difference between the 2? The single equal assigns, the double equal compares. Gotta remember that. So if I do this, something like this, while this, right? And I'll move this over so you can have a better understanding. All right, and then I'll do this. All right, so while this, and then I'll have something like while choice is equal to y. So remember the while loop, I have to set it so it can fall in. You understand? Otherwise, it will never fall in that loop. So now, once I'm in, now I could say something like, get the 3 values, see out, I'll do it just like somebody did, all right. Because we know I have 3 numbers. All right. Now, then here I would have something like this, C out. I'm gonna do a double C out. I'll say C out, I'll just say do again, all right? And I'll just do something like y/n, and it's not the right one. All right, y/n, and then I'll say cn choice. All right, so the while loop says what? As long as I type in a what? As long as I type in a y, it's gonna continue to perform the whatever in here. When I type anything other than that y, it's gonna kick on out. All right. So let me run it. Ma'am?
When I try to do that for the homework, do you have to like? I looked it up and I looked in the book. I couldn't find it, but do you have to put a hashtag include whatever for it?
What now?
You know how when you use certain things, you have to put a hashtag include for it. Do you have? Is there one for this?
No, because we're not doing. There's no input file. Which is F stream. You don't need nothing for a loop. Loops is just standard code. So
For
I know
character.
for character. No, all you need is char. But now if you did a string, if you did like YES, like the whole 2 or more characters, then you would have to do string. You have to load the string library and make it string, like say string whatever.
Okay.
Right. But other than that, if it's char, char is just a regular variable. Right. So let's debug it. Now I might have to do the cn.ignore, which I think I do though, but we'll see. All right, so it's in a value. I'll say 3, 3, and 3. Okay, average is 3. Do again, I'll say y. In a value, 4, 4, 4. So 4, 4, 4, the average should be what, Claire?
4.
4. What it did, it added 3, 3, 3 and got what? The total is what, 9, right?
Mm-hmm.
Then it added 4, 4, 4, the total is what?
7.
Well, the total of 9, 4, 12, 12, right?
Mm-hmm.
So 12 and 9 is what?
21.
21 divided by 3 is what?
7.
7. So what did not do in order for me to get the right average? What did not do? Looking at this output, what did not do? I did not set what?
Average.
Not average. I did not set
The value.
what value?
4.
Huh?
4.
What value?
4.
4. No. Let me ask you this. If I was doing each student's average in the class, right?
Mm-hmm.
When I added your average up, and we looking at the program, when I add all your values up, I'm putting them in what variable? If each person had their 3 scores, in this program, what I'm putting the value in of those 3 scores?
Total.
All right, total. So every time I calculate an average, I need to set
A value for total.
back to what?
0.
0. You understand? So that I can start a new accumulating a value, right?
Mm-hmm.
You got what I'm saying? So what's going to happen is I got total set to 0 here, but I need to, okay, I'm doing this. I'm adding, print out average, whatever. But what I need to do after I print out average, I need to do what?
Again.
What I need to do here?
Do it again, but for 4.
What I need to do? What we say we needed to do each time we do a new average?
Give it a new value.
What about this?
Oh.
Right?
Yeah.
So that way, when I say y and I come back in here, total is equal to total plus num. The first time, always total will be what? 0. So I done set it back to 0, so each student will get the proper what? Average. You got what I'm saying?
Mm-hmm.
Because I'm set. See, I'm doing 1, 2, 3. I'm adding them up. I'm printing out the average. I printed out the average, but I need to set everything back to like I'm starting over again. So set total back to 0, then add them up, So let's run it again and let's see what happens. All right. But you see how you logically, you got to be able to go through your program and understand what's happening. So let's look at it. We'll do the 3-3-3 and the 4-4-4 all over again. What done happened here now? Oh. All right. So we do 3-3-3, right? Got 3. 4. Oh, wow. Oh, I know what I didn't do. I didn't type Y. I'm typing the numbers again. Okay. 3-3-3. Hit enter. Do again. Y. Hit enter. Value 7-7-7. What should I get? What I should get for the average here?
7.
7. Right? Look. See, because total was set back to 0. Do it again. Yes. I'll say 2-2-2. Right? So as long as I put in a Y, it's going to continue to loop. It's going to continue to loop. It's going to continue to loop. As soon as I put in any other character, say, but I'll put it in, but any other character, because I just said what? While choice is equal to Y. Remember? That's all I had. So when I hit that, do that, our program is complete. All right? So you understand what happened, right? Everybody see that? I have to set this back to 0, but I can't set it to 0 inside of here, right? If I take this total equal to 0, I want to copy, I want to cut it. Let me see if you got your thinking caps on. If I put total equal to 0 here, what happens to my program? Look at the logic. What happens to my program?
3.
Huh?
0 divided by 3 and 0 divided by 4. And
So every time I do my average, look, every time, well, first of all, every time I do this loop, what am I doing? The first time through, if I enter 3, it's going to say CN num, I'm going to enter 3. 0 is equal to 3 plus 3. I mean, 0 plus 3. So it's going to be 3. But what I'm doing here, setting it back to what?
0.
0. So it's going to do that 3 times and it's going to set it back to 0. When I come out to average, I'm going to say average is equal to what? What divided by 3? 0 divided by 3. So you understand? So I'm going to get 0 every time I run my program, which is a logical error. I won't get no syntax error, but every time I run my program, I'm getting the wrong answer. See, I got 0. Yes. 0. And I'm going to put 100. 100, 100, 100. 0. Because I'm telling it to what? To set it equal to 0. You understand? And what? I need it in there, but it's in the, logically, it's in the wrong place. Everybody see that? It's in the wrong place. All right? So any questions? So this needs to come out of here. All right? And it needs to go back here, right before the do again and get back to the beginning. Or I could have put it, I could have put it down here, long as it's before it returns back to the beginning of this. Total equals 0. I could have put it here, in between here, well, you don't really want it in between here, but you can. But like I say, as long as it's before this end of this while, where it's going back to the beginning and starting over. All right? So I think the next parts of the program, deal with data storage of the files. All right, and we talked about input files already, right? But like I said, they talking about the different file types. Like say you got text files, which is the files you're going to be creating. Binary files. Well, no, then there's binary files. Binary files consist of what characters, class? Anybody?
What files?
Binary. What kind of data you would see?
Zero.
Huh?
Zeros.
Zeros and ones. That's all you're gonna see in a binary file. All your data gonna be stored as zeros and ones. You won't see text files like A, B, 5, 7, whatever. You're gonna just see a whole lot of zeros and ones. All right. Now, you can access your files randomly, or you can access them sequentially. Sequential access is an example of a cassette tape. How many people have had experience using a cassette tape? If you have, say, 10 songs on a cassette tape and you was at the beginning of the tape on one side, to get to the last song on that tape, you got to do what? Fast forward through all of those songs to get to that last song. That's sequential, step by step, one by one, until you get to it. Now, if in today's society, we've advanced, even though they still use tape to store data and whatnot, but we have random access. Random access is more or less like your CDs and your CD players, because now you can randomly play songs, you can randomly select songs. You know, you don't have to go through the CD and go one song at a time. I mean, from first one to the next one to the next one. You can let it randomly select what song you want to play, etc., what folder, whatever. That's random access, which is a lot faster. All right. And it's showing here the different like different types of files. .jpg, we know if you take pictures with your phone or whatever, that's image files. .txt, we know normally that's text files. And .doc, we normally that's pretty much document files, and it could be almost any word processor or whatever. We talked about F-stream objects, and like I say, we talked about that earlier. Look, F-stream, then you got IF-stream for input files, OF-stream for output files. You got to be careful with this, because if you're trying to create the input file and you're using OF-stream, you won't be able to read from it. IF streams allow you to read. OF streams allow you to write too. So you gotta pay attention to that. Look here, IF stream, the object, then the object dot open, and then what? The name of the file .txt. All right. So that's some of the stuff we already went over. Output file, OF stream, output file. Then out file dot open, and this would be a file that would be created when you writing your data to your output. All right. So we went over that. We also looked at this. You can't use a single backslash. You got to use //. If you wanted to access a specific folder or whatever, you would have to give it the drive name. The // because one. It's just one, you're gonna get an error. It won't know what /D is. All right, it won't know what /I is. All right, so that's how you do that. Then housekeep, well not yet, but IF stream for input, OF, and this is just another way of doing it. You could do it this way all in one. IF stream, input file object, and then the name of the file. All right, but closing the file, housekeeping. Make sure you close the files out. Writing to a file, if I want to write to it, rather than use cout, I'll use the output stream. And we looked at that already earlier. If we want to read the file, we have to use the input file stream. Now, class, these are some small programs you can look at to see what's going on. Now, this program writes these outputs to a file called demofile.txt. So they created the F-stream, or they loaded the F-stream library. They created the object for the OF stream, and then they opened the file using that object. And then each time they wanted to write to that file, they use out file rather than cout, and it's going to the out file. But they use cout here to say done, so they know that the program has completed. And now, then they show you some examples of, well, this is still some of the same stuff, but they're going to show you some examples of how to check to see if your file exists. Let's see what it said. Okay. Reading data from a file. we don't went over that part too. When you're reading the data from a file, you read the first one, next read, gonna read the second one, next read, gonna read the next one. All right. So we did the numeric. It's gonna read till the end, till a blank space, read till a blank space. Where I'm trying to find, okay, this is the loop. Okay, here. For int count equal 1, count less than number of days. But that's if you know how many records you have in your file to retrieve, or how many times you want to pull it out. All right. Okay. Detecting in the file, we did that one. Look here. Let's see where it is. Right here. See here where it says, no, where it is. Where it is. No. It would be the next one. Right. See, if input file. It's just asking if the file exists. If the file exists, read from the file. All right? Read from the file. Long as the file exists, read from the file. Okay, look. But then remember I had the not in the file, whatever. But then look here, while input number. So they got it a little different. They didn't say while not whatever. While whatever, do your input. So there's several ways you can write code and it's not incorrect. So this the part I told you that checks to see if the compiler is locating your input file. So see here, you set your IF stream object, and then you open it, and then if input file dot fail, now this would be whatever your object name fail. Then you say you got an error opening file. So something going on. Your file name is spelled, your file in the wrong location, or something. And you have to figure that out and fix it. Otherwise, continue on with whatever process you're trying to do. All right? Make sure you specify your file names correctly and whatnot, because if you don't, you can run into issues. All right? So this is just some other help. But like I say, all this we covered mostly, and that should help you write your programs that are assigned to you. All right? Nested loops. We talked about that loop within a loop, which is that first program you have to write. They talk about the continue. The continue statement allows you to break out and continue on. The break statement, is it break or quit? It breaks and takes you out altogether of a process. So you can use either one. It says the continue statement causes the current iteration of a loop to end immediately. So you exit out and you're going on with the program. All right. In a while loop, this means that the program jumps to the test expression at the top of the loop. All right. All right. As usual, if the expression is still true, the next iteration begins. In a do while loop, the program jumps to the test expression, all right, at the bottom of the loop, which is the bottom, like say, because the while is at the bottom. All right. So it's just giving you some of those other commands. All right. All right. So this is pretty much the chapter. I have the tests, we have the assignments, we have the quizzes, and hopefully, like I say, you can go over this information and then take your tests and your quizzes. Our next class, I'm gonna send an email. The next class period, we're gonna do the same thing, have it in the evening also, because I'm gonna still be in another workshop, man. But anybody have any questions? If no questions, like I say, text me. Email me if you got issues or whatever with the programs or whatever. Or like I say, contact each other or whatnot. All right.
Yes, sir.
Questions? Okay. All right. So if no questions, like I say, have a good weekend, and I'll see y'all next weekend. Next class period.
Yes, sir. You too. Thank you.
All right. You're welcome.